In this video lecture session, we are going to discuss about the configurations of transistors, different configurations of transistors. The previous video session, we discussed common emitter configuration, but in this video lecture, common base configuration transistor. So what is common base configuration? Here base terminal is connected to ground. This is base terminal is connected to ground. The input terminal, emitter, between emitter and base. Output, collector, between collector and base. Right? So the base is common between emitter and collector. Right? Here the input voltage applied between emitter and base, output voltage between collector and base. You see the circuit diagram. This is the common base configuration of transistor. Right? This is the circuit diagram for determination of input characteristics and output characteristics. So this is base terminal. Base terminal is connected to ground. Then the input terminal, the output terminal. Output voltage, input voltage. Input voltage is VBE. Voltage between base terminal and emitter terminal. Output voltage between collector terminal and base terminal, VBC. VBC, this is VBE. Here, diode, we can apply only one biasing. If the diode respond, forward bias. Right? Reverse bias, the diode can act as a open switch. But here, two biasings are made by transistor. Forward bias, one is forward bias and another one is reverse bias. Always input is forward bias and output is reverse bias. Because here two diode analog is there, PNP and NPN. For due to the two diode analogy, here we are giving two biasing. The input is always forward biasing, the output is always reverse bias, right? So two different bias are given to the transistor operations. The input, then currents are input current. Current flows through emitter terminal IE, current through base terminal IB. Similarly, current through collector terminal IC, and then voltage across C and B. Collector and base is VCB. Input voltage emitter and base terminal VBE. Right? So this is the circuit diagram. The input resistance, this is the load resistance. Now, what we can do for determining the input and output characteristics? First, we see the input characteristics. This is the input characteristics. In this input characteristics, we can vary the base emitter voltage, but the output voltage VCB is keeping constant. Output voltage keep constant by varying the input voltage. You see the diagram, circuit diagram. Output voltage keep constant, but input voltage is going to be varying one. With the help of this variable resistance, with the help of this voltage, sorry, with the help of this varying the voltage, right? But we can make the output voltage between collector and base keep constant. Now we varying the input voltage, but we can make one set of output voltage. For example, the output voltage is 1 volt. We set 1 volt and we do not change further. We do not change further voltage. But input can vary. Input can vary. Right? By varying the VBE, by varying VBE, varying the input voltage or one set of output voltage, and note down the VBE value and the input current IE value. See the characteristics. Or varying the VBE value and the IE value, and collect the all values and draw the different set of output voltage. VCB, one set of VCB can draw the input characteristics. Similarly, another set of input voltage, we can another set of output voltage VCB2, we can draw the input characteristics, right? But always VCB2 is greater than VCB1. For increasing for various set of value, we can set the output side, but every time can increase the voltage, output voltage side. For one set of value, we can make the input voltage and input current. Again, we can raise the another set of output voltage. We can note down the another set of readings, VBE and IE. Again, we change the output voltage. For example, VCB1 is 1 volt. Take down the readings, input readings. Again, varying the output voltage from 1 volt to 2 volt. Again, note down the VB and IE values. Right? So for every time the output voltage is going to rise one. So VCB2 is greater than that of VCB1. Suppose we can take another set of reading VCB3. So VCB3 is greater than that of VCB2 is greater than that of VCB1. Right? So this is the input characteristics. By using this input characteristics, we can also calculate the input resistance. So input resistance is equal to del VBE by del IE. Del VBE by del IE. Del VBE stands for change of base emitter voltage, input voltage, right? Del IE for change of input emitter current. So the ratio between change of input voltage and the change of input current. But the VCB is constant. For one curve, for one set of reading, a constant, another set of reading also constant, right? So this is the determination of input characteristics of common base configuration. So this is another configuration. Output, another common base configuration is output characteristics. The output characteristics here, input current, we can make the input current is constant, but the input characteristics, output voltage constant, but here input is keep constant, right? And by adjust the VCB value for various values of VCB, we can draw the input current IE1. For example, IE1 is 1 milliampere. We can set the IE value 1 milliampere and varying the VCB value, note down the output current and output voltage. Again, can change the input current IE2 1 milliampere to 2 milliampere. So again, varying the VCB and note it down the output voltage and output current for constant IE2. Again, change the another value. For example, 2 milliampere to 3 milliampere. I am saying that example from 1 milliampere, IE2 is 2 milliampere, IE3 3 milliampere. For third set of reading, the input current IE3 is also constant. Then varying the VCB value, note it down the VCB and the IC value, and draw the another set of output characteristics. Here IE3 is greater than that of IE2, it's also greater than that of IE1. You see, this is the output characteristics. From the output characteristics, we can also calculate the output resistance and the output current gain. So output current gain is the ratio between output, the change of output current. Collector current is output current, the change of input current, but output voltage is kept constant from this tangential line. From this tangential line, the change of this is the input current, this is output current, but VCB is constant. But here the output resistance, output voltage to the ratio between output voltage and output current, but input current is constant, right? So from this output characteristics, we can identify three set of operating region in the transistor. One is saturation region. This is the this is the cutoff region. But cutoff region is the collector current is very low, right? So after varying the VCB, then the collector current starts to rise for different set of input current. So this is operating region. This is operating region. And after some time, the collector current is going constant. So at the time, the collector current is saturated one. So at the time, the output current is constant one. So three set of operating region is there. Cutoff region, saturation region, and operating region. Cutoff region, this is cutoff region. The cutoff region, the transistor never operates, but in this operating region, the output current starts to rise. In the saturation region, the output current is keeping constant, right? So this is the different operating region of transistor. Similarly, for common collector configuration, here collector is going to be ground terminal, then base is input terminal, here emitter is output terminal. Now emitter is output terminal. A connection is given as per the circuit diagram. The input voltage is given to the base and collector terminal, output voltage from emitter and collector terminal. Input current is base current, output current is emitter. Right here, the output voltage VCE1, VC is constant, keep constant for one set of value, and varying the collector and the base terminal. Collector and the base input, we can vary the input voltage, note down the input voltage and the input current, draw the input characteristics for one set of value. Similarly, we can set the another set of output voltage VCE2, another set of input voltage, can set the another set of output voltage. Again, we can vary the input voltage VCB and note it down the input voltage VCB and IB and plot the curve, right? So here the two different set of output voltage. The output VCE2 is greater than that of VCE1. Okay, this is the input characteristics. Similarly, this is output characteristics. The output characteristics here, input current is always constant. Input is base terminal. For different set of input current, we can draw the output characteristics by varying the output voltage. Note it down the output voltage and the output current, because here the emitter is output side. For different set of values, take the different set of values at constant value of IB1, right? Then draw the output, one set of output characteristics curve. Again, we can set the another set of output, another set of input current. This is IB2. Again, we can vary the output voltage, note it down the output voltage and output current, and draw the another set of readings for the output characteristics. Again, we can set the output we can set the input current IB3 input current. Another set of input current IB3. You can vary the VC, note it down the VC and the IE and plot the curve for third set of input current value. Right here in IB3 is greater than that of IB2 is again greater than that of IB1. Here this is the saturation region, operating region and cutoff region, operating region and saturation region. So in this characteristics for CC configuration, this is IB, this is input current versus output current, but keep the voltage output VC is kept constant. Right, by using this curve, we can draw the output current gain. Right here, by using the output characteristics, can draw the tangential curve and draw the tangential curve. We can calculate the output resistance. Output resistance R is equal to del VCE by del IE. Right. So this is the different configurations of bipolar junction transistor. Thank you.